for our calculus class. Okay, so a 10 centimeter tall funnel is being drained at a constant rate, 10 centimeters cubed per second. The mouth is 12 centimeters in diameter. How fast is the solution dropping when there are 200 cc's left in the tunnel? So what we'll first do is draw a picture. Record the picture. Okay, and we'll label all our givens. So we're giving that the height of the funnel is 10 centimeters. 10 centimeter tall funnel is being drained. So it's being drained at a constant rate, which means the volume is dropping dV over dt, and since it's being drained, it's going to be negative 10 centimeters cubed per second. And the mouth is 12 centimeters in diameter. So if the diameter is 12 centimeters, then that means the radius is 6 centimeters. 6 plus 6 is 12. And how fast is the solution dropping when there are 200 cc's left? 200 cc's left would be the volume at that instant. That's 200 cc's. And now what we're trying to find is how fast is the solution dropping when there are 200 cc's left in the tunnel. So we're trying to see how fast the solution is dropping, so we're looking for the height, dH over dt is our question mark, and that's going to be in centimeters per second. And now our equation. The equation to relate all of this together would have to be the equation for the volume of a cone. The equation for a volume of a cone is 1/3 pi r squared h. So now when we go back to labeling our picture, we know that this is 6 centimeters, that's the radius, 6 centimeters, and then the height, which would be the big H, is 10 centimeters. And then we know that dV over dt, that's dropping. So, and our solution is somewhere over here, and it's dropping, so it's forming a puddle. But as you can see, the solution here makes a triangle, and it's part of a bigger triangle that it's inside of. So we can pull that out. So we pull out the big triangle and the little triangle, and we relate them together. So that would be 6, and that would be 10 centimeters. So now that we're trying to relate these two together, and this is that's R, and this is H. So now we do the ratios. R over H equals 6 over 10. That reduces to 3/5. Cross multiply, that gives us R to the 5th equals 3H. Since we're solving for dH over dt, we want to keep everything in H's. So we divide this by 5, divide this by 5. Our new R is 3/5 H. That's our new R. And now we're going to plug this into this equation. So we'll have only one variable. So V equals 1/3 pi 3/5 H squared, everything squared, times another H. So now when we square this, we distribute this here, here, and here. And now we have V equals 1/3 pi 9/25 H squared times another H is H to the 3rd. So now that we have H to the 3rd, we can move on to figuring stuff out. We'll take the derivative of this. The derivative of V with relate to time is dV over dt. And now chain rule here, we bring down 1/3 times 3 pi. Those 3's cancel. 9/25 H squared dH over dt. And now we just have on our new sheet of paper, we'll just have 9/25 pi H squared dH over dt equals dV over dt. So we know what dV over dt is from our givens. We know we're looking for dH over dt, but we don't know what H is. We need to know what H is. So if we go back to this equation right here, we can figure out H. All we'll have to do is plug this in, because we know it's 200 cc's. So we're going to plug this into here, and we'll get I'm sorry, actually we can plug this into, okay, yeah. We'll just plug this into here, into this equation, since we have our h's. Well, I'm sorry, this equation, we have our h's. So it's 200 equals 1/3 pi 9/25 h to the third. H, right here, what we're trying to solve for. So now, multiply that, that's 3. So you have 3/25 pi h cubed equals 200. You multiply by 25 pi over 3 times 25 pi over 3. That times that, 5,000. Pi over 3 equals h cubed. Take the cubed root. Now we have h equals the cubed root of 5,000 pi over 3. If you plug this into your calculator, you get 8.1. That seems a little easier, so we'll just deal as h as 8.1. Now that we have our h, we can plug this back into our equation here. Our equation here, once we took all the derivatives. So now we have dv over dt equals 9/25 pi, and h, plug this in, which would be 8.1 squared dh over dt. dv over dt was given to us, that was -10 centimeters cubed per second, equals 9/25 pi, 8.1 squared dh over dt. And now when you plug all this into your calculator, you should end up with dh over dt equals -0.134 centimeters per second. So that's how fast it's dropping. And that's it.